Welcome, everybody. We're going to be working on Module 6 this evening. The grand topic for Module 6 is working with external files and making them part of your programs. And we're going to begin with reading up a little bit over at W3 Schools about one of the methods for reading files into Python programs. And we're going to take a look at this really simplistic example here. And I just want you to look first at the code. This is an example where we run a function called open, right? And what that does is, as one parameter, it lists the actual name of the file that you're opening. In this case, we're using a text file. And here's one of the secret sauces of all of IT. Most everything on a computer system, in truth, is actually a text file. Even images, even videos. Ultimately, if you can look inside them, they're text, sort of, right? Unless they're binaries, then they got really weird characters, but they're still technically text. The other parameter that we see here is a switch, which would, in this case, the R switch reads the file. That's all it does. It just reads it in read-only mode. So what would happen with that command is it looks in the same folder that you're in for a file named exactly this. Upper lowercase, it's got to be precise. One letter cap here when it's not in the file name, and it won't open, by the way. So you call the file. This assumes it's in the same folder. If it's not in the same folder, you would append a directory structure to the beginning of the file name. We're telling it to open in read-only mode, which means we're just going to read the contents, and then we're letting go of the file, right? The contents, then the file basically ends up in this one variable called F, One of the conventions that I always use when I'm teaching at the other school is I call it in file. So I know it's an inbound file, or some people will shorten it to INF or whatever. But the entirety of that file is now in that variable, a single letter variable, which is kind of mind blowing because it could be a couple lines of text or it could be 100,000 lines of text. Pretty weird. Once we have it in that format, then we can run methods that work with files. One of the methods that works with files is the read method. And what the read method does is it reads the file. And of course, if we want to print the file, being able to read it is pretty helpful, right? So the read method returns a specified number of bytes from the file. The default is -1, which means the whole file. So let's run the example here so you can see what's going on. Now, we can't look at the demo text file because that's somewhere on the W3 servers, right? But this is what's in it. So we are able to just put that up on the screen. Right? Now, it seems very simplistic, but the ability to open up a file that's not the file that you're working on is kind of powerful, especially if that file contains data. And so for any of you like that are in the like the data analytics or AI track where data is really important, being able to read in a file is huge because often you'll get a dump or a report off of a database. You might get a CSV file or a tab separated file or something like that. And to be able to read it in and then utilize it in your Python program, very powerful, very, very powerful indeed. Another little example here, right? This one here, 33, what does 33 do? Well, if you start counting the letters here, it reads the first 33 characters is what's that doing. Now, why you would want to use that, I'm not really sure. But you just want to read the first 33 characters of a file, or maybe you want to read the first 100 characters of the file. And there is a practical usage for that. You might not think of one initially, but sometimes if you're writing code, you want to see, can I access the file? Let's just read in the first part to see if it's working. Okay, it's working, right? And then you do something else with it. But it's usually for testing purposes that you would do that. But that's all it takes to do that, that little maneuver. So let's go ahead and go back to the lab now. and take a look at what they're asking us to do. So it's actually pretty simplistic. It says in your project folder, create a directory called lab files one, right? And you can call it whatever you wish, right? Create a text file in this folder called hello world and enter the following text with your first and last name. So let's kind of mechanically do that process together. I do have my file folder here where I have my module 6 labs. Inside here, I'm going to go ahead and create a new folder. And they told us what to name it. So I'm going to follow this precisely, by the way. So a new folder called lab 1 file. So capital L, number 1, capital F, no spaces. All right. Going into the folder, and now I'm going to right click, and I'm in Windows 11 now. So, you know, if you're on Windows 10, you might have slightly different menus here. The Windows 10 menus look more like this, right? But what we're looking for is a new text document. If you're on a Macintosh, you might have to open up TextEdit to create a new text file. If you are on a Mac and you're using TextEdit, please make sure that you're saving that file with a TXT extension. So it doesn't, otherwise it'll become rich text. All right. So once again, in Windows 11, I go to new, I choose text document, it pre-creates it for me, and I am going to call it hello dash world. All lowercase and a dash in between, no spaces. Right. Another thing I kind of want to do is a really quick little thing here, and I know we did this at the very beginning of the course. You know, I always talk about file management and how that's important and kind of like a forgotten skill these days. You'll notice here as I'm putting mine together, my file extensions are visible in advance. Yours may not be. So I want to make sure that you guys are aware of this, right? So please use this triple dot menu. If you're on Windows 10, it might even be on the ribbon bar under View. Go to Options, go to the View tab, and then right here, there's a little setting that says Hide Extensions for Known File Types. Notice how mine is unchecked, but check it out. If I check that and click Apply, and then come in here, create a new text document, and then I call it hello-world.txt and press enter, the reality is I now have a double file extension. And this is what I'm trying to prevent you from doing. By unchecking this box here, you can keep that problem from happening. Because here's the problem. When I'm in a Python program, remember I told you that the file name must be exact, not even one character can be off. This would be off because notice it's called txt.txt. And I don't see it because my file extensions are obscured. Right. So if you guys run into this, let me know. But I do have the correct one here. I'm going to open that one up. In Windows, the default text editor is Notepad. That's where it's going to right now. And then I'm going to come in here and copy their text. Paste it in. I'm going to put in my first name. And, you know, if you want to put more stuff in the text file, go for it. Right? It doesn't matter how much stuff you put in there. Once you've typed your stuff in, make sure you hit save. You can leave Notepad open while Python is accessing the file. It won't harm a thing. Text files tend to not be that finicky, by the way. So I'm just going to leave this open in the background. And now that I've got that here, I'm going to go up one folder level to create my Python program here, right? This is going to be a little bit weird, but that's how we're doing it. I'm also going to get my cheat sheets moved out of the way here. All right. So here back in Visual Studio Code, right, you'll notice that we do now see our folder where that text file is, and I can expand it. So I see both versions, right? The one actually has the text in it, the other one's blank, right? So I'm going to close that one, but I do want this one open, right? We can look at it, whatever. But I do want to work up in the root folder here. So I don't want to be working up here. So I do want to create a new file, but you notice where it put it in that folder because I was sitting in there. I'm going to press escape and I'm going to come up here and see if I can do this from up here. I think I might have to just create it and then move it. So let's just call it mod 6 lab 1.py, and I'll move it in the aftermath. So I'm just going to click and drag it up if I can. Okay. Does it have a little move thing in here? Doesn't really like that, does it? All right. So since I can't seem to do it within the IDE, I'm identifying another reason why I don't like VSC, by the way. That's one of them. Bad file management. So I'm going to my file system to do it. That's pretty pathetic, actually. But I did it. I made the maneuver. And now you can see it's sitting in the right spot. All right. Now that I have my file here, I'm going to follow what they told us. Now, they called their file their variable f. If you want to do that, go for it. I'm going to call mine file. And then I'm going to use the open command, and then the open or function, actually, two parameters. The first parameter is the file. The second parameter is the read write mode or whatever. So I'm going to put in like what you would think, right? The file's called hello world-txt, right? And comma, and then the read switch. Okay. However, it's not in the same folder. So we have to append to the beginning of it the name of the folder. So I'm going to say lab1 files. This has to exactly match. The folder name has to exactly match, and the file name has to exactly match. Not one character can be off. Upper, lowercase, all of it is important. Right. You will notice, right, even though we're on a Windows system, the folder slash is a forward slash like we would use on a Unix or Linux system or a Macintosh. Tells you a little bit about the origin of the technology. And the truth is, folks, Windows is the anomaly. Windows is the one that does backslashes instead of forward slashes. Every other system uses forward slashes. Interestingly, Windows now kind of supports those too. So that's what we have to put in our code. This will work on any system. Right. So now that we got this typed in, we can take a look at the file. So why don't we, let's goof around with this a little bit and experiment. And I want you guys to do this. The first command I'm going to drop in is the same one they did at W3 School. So I'm going to take the file, I'm going to run the read function or method on it, and then print, we'll be able to put it on the screen. Let's just do that, see if it works, right? So I have a control S to save here, and here comes the run. That out of the way. So you can see it read the file, read the contents, put them on the screen. So if it did not work, so it's possible it might not have worked for you, you either have the double file extension problem, you didn't call the file correctly or the folder correctly, or you use the wrong syntax. Everybody's okay? Okay, that's good.
So sorry, I'm not. For Apple, what was it that I need to call it again? Like, what did I need to not have it as? Think I missed that for Apple.
Okay, on an Apple platform, when you name your file, it will automatically obscure the file extension,
Mm-hmm.
right? But when you're saving it, make sure that the file extension, like in the save as dialog box, is txt, .txt.
Okay, that's right. Okay,
Yeah.
thank you.
Because otherwise I think it defaults to RTF, rich
It does.
text file. Yeah.
Okay,
Yeah. And that's problematic. It's a different file format and
perfect.
it won't work as elegantly, basically. All right. Um, I'm looking at some of my other little functions here. All right. And I think we're at a really good spot for a break right now. Let's take a break. We'll come back and tinker with this some more. All right. So let's call it a 5-minute break. All right. We're back from break and I'm looking at the instructions here for our little lab exercise. And we have successfully at this point done these first 2 steps, or I guess 3 steps with the text. So we created that, named the file, put the text in there, and we did this, right? So I'll put the contents using read. And then I notice as well as a for loop. And it says complete this as directed in class. All right. So I have like a bunch of little stuff I want to kind of pepper in here that we're going to play with a little bit, right? Before we kind of finish this up. So kind of experimenting and seeing how this stuff works. Now, the read method or function kind of automatically takes the text file as it is and allows the print command to just output it on the screen. Sometimes that's useful, and sometimes that's not what we want exactly. Sometimes we only want certain stuff from the file, or we want to be able to take the text in the file and process it line by line. So I want you to think about this. This is a text file that contains like kind of pedestrian speaking words, like, my name is, that kind of thing. Where a lot of text files that you will actually work with in Python might happen to be data files that contain maybe a dump from a database or output of some sort of other file format or the result of like running a query or something like that. And it might be in a different format where we do want to look at the information line by line. So that's where a for loop comes in pretty handy. So I'm going to go back over to VSC here really quick. And I'm going to create a for loop here to kind of go through the file. Now we've already proved that this print command works. So I am going to comment that out. I'm just going to put a pound sign in front of it. And I'm going to set up a for loop and I'm going to use this syntax here. And this is, by the way, a really nicely paired structure, like a for loop that traverses a text file actually works really well because as it traverses a text file, what it does, and this, maybe I should bring up the text file here. It looks at the text file in this fashion. It reads a line. When it gets to the end of the line, we don't see it, but there's a character in here that's called a line feed. And basically what that does, it's like, okay, this line's over, go to the next line. And then we go to the next line. There's no text here, but there is a line feed character. Then we read a line of text, line feed, line feed, line feed, and then it's the end of the file. And by the way, in IT speak, EOF, right? And in the old days, we actually used to use that nomenclature to describe it. But the point is that what a text file actually is, and if you guys remember when we started taking words apart and we're like, well, a string is really a list of individual characters, right? And that would be like position 0, position 1, 2, 3, 4, 5 characters. Well, that list structure also applies to a text file. So this is line 0, this is line 1, it's blank. This is line 2, line 3, line 4. So those have index numbers too. And because of that, what we're basically saying is that a text file is really a list of characters, right? So like each word is a list of characters, right? But it's basically a list that contains strings. And therefore we can treat it as that data structure automatically because that's how text files are built. And therefore we can traverse it with a for loop like we can any other data structure. And in Python, this is fairly automatic, and that's what's kind of neat about it. So the syntax I will use here, I'll say for each line, in the file. So to read it one line at a time, I'm going to do a couple of weird things here. So the first thing I'm going to do is I'm going to take the line and I'm going to run a function on it, which is kind of weird. And this function's called rstrip. And what this does is it strips leading and trailing spaces from the line of text. Well, this is kind of a weird command to throw in at this point, but this is actually very useful when you're processing data or when you're dealing with user input that might have extraneous characters in it. So it strips away junk and leaves you with the core information. Is really, could I do this without doing this step? Yeah, I could. And in fact, I'll comment it out and show you what the difference is. But let's get to the print command. The print command's coming next. I'm doing this with string interpolation. So I'm using an F string, and then I'm saying, I'm just putting some text in here. I'm going to say line I. Oh yeah, I wanted to create a counter variable. I'm going to do that right here. So I'm going to say I equals 1. And we're going to do the numbering thing, right? This is just for the screen again, not related to the index values, right? And then we will output the line of text. So we're going to put in, we're going to say line 1, here's the text. Line 2, here's the text. Line 3, here's the text. And then after we do that, then we will increment our counter. The counter is just for visual sake. All right, I'm going to go ahead and save this and run it. I mean, it's not like miraculous output on the screen, but it is doing it. Are you guys noticing anything else that it's doing? Yeah, I mean, you wouldn't catch it, but I'm going to show you what the difference is here. Like if I add a space here and add a couple spaces there, save the file, and then run the program again.
Counting each line.
So the assumption is, oh, it would have got rid of those spaces, right? Yeah, it actually doesn't do that. Here, let's do a really quick lookup here. Python rstrip, what it does. It's used to remove trailing characters from a string, right? And that includes spaces, tabs, new lines, or anything like that. So it doesn't remove it from the beginning, but it does remove it from the back end of the text. Why we do this, and I think I kind of explained this, right? Like, so the habit that we have as users when we're working with text files is like we type, we hit space, we type, we hit space, we type, we hit space. And often when we put stuff in, we don't want that space at the end. We don't want to count that, right? That's the why. So here we do have a couple at the end, and I can't really display that like in the console, unfortunately. But I am like messing up my text file here pretty good. So I'm going to get rid of all that stuff, get it back to where it was, and hit S, Control S to save. But that is a standard thing that we do, especially when you're getting input from a user, right? If they typed in the text file, it's not a bad idea. All right. So there's an example of a for loop kind of doing this task. Now, the other thing that I want to do is I want to demonstrate a couple of other methods that we're going to kind of be digging into here anyhow. And one of them is this method called tell. And what I'm going to do here is I'm going to do a print command. I'm going to pull in the file, and then I'm going to run the tell method. And what the tell method does, and I have a little note here, right? The tell method shows where we are in the file. Okay, so I'm just going to go ahead and run this again so you can see what it does. Right. Well, at this point, it was at position 0, right? Where are we in the file? You're at the first character is what it's telling you. Why are we at the first character? Because we just read it in and we didn't do anything, basically. Right. There's also this other method, and we're not really super worried about it at this point. Okay, bad copy paste there. Let's try that one more time. And I'm pulling this in this way. So these are coming in as comments. So I'm going to uncomment them. But we also have the seek method, right? Which positions our cursor to a specific spot in the file. So if I wanted to go to position 20 or position 50 or whatever, I can put that number in here. This will put us at position 0. And then we can read the file again. And I know this is kind of redundant here, but I probably should have done this in a different order. But what it's doing, right, if you guys aren't picking up on this, is it is going to that position 0 and then outputting it from that position. Right. We'll come back and look at these. I'm going to comment these out, but I just thought I would just do a little honorable mention at this point in time on those.
Oh, really?
All right, and close the console. I'm going to call this lab complete. I think we completed all the tasks, and I'm trying to get to the instructions here, which are here. Right. All right, complete as directed in class. We're done. All right, so I'm going to move on to the next lab here. And we're still going to be working with the read file method. And let's take a look at what we're going to do. So it says conditions in conjunction with the file data is a great way so simply to simply examine the files for content. So once again, we have a typo here, and I apologize for that. So being type A personality, I guess I am, I want to fix it right away. So I don't forget next time. All right, fixed. All right, we're still using the same methods here. All right, so I'm going to have you guys download these 2 files here, and I'm going to first click on them. And what's kind of interesting about this is Canvas will actually load it up on the screen. But what we have here is a text file that has some dialogue from the B movie, right? And the way that it works is basically you have the character name with the colon and then what they said, right? That's the way the file is structured. There's also one for the Shrek movie that's the same, right? So dialogue from Shrek, you notice that there's like square brackets for sounds and, like belches and record scratching it and whatever. But once again, the basic format is the character name and then what they're saying, right? And I'm not the one who chose these movies or these files, by the way. You can blame Patrick for that one. But if you want to download them, hit the little arrows and do that. So download them to your machine. And then we're going to need to put these in a folder, once again, in our file system. So I'm going to go to my file management here, and I'm going to locate my work for this semester, which we are in module 6 labs here. And I'm going to create a new folder called lab 2 files. And then I'm going to go to my downloads folder and grab those 2 files. You can see I have them from before. And so I'm getting the parentheses 1 on each one of these, but I'm highlighting both of them. I'm going to cut them and then move them over to this folder and paste them in. I am also going to rename them to remove those superfluous characters. Thought it was renaming it. Okay. Okay, that's a really weird effect. You guys catching what's happening on my system? Greg, you got a question?
Yeah, just apologize. I was thinking about this. I'm having trouble with finding the file on the first lab, and I thought I was kind of chewing on it, and beating on it. Is there a difference? I've got all my stuff shoveled up in OneDrive. Does either the IDE or Python make a difference between where it's actually stored. I mean, I think yours are all on the local machine, but if it's stored up in a different place, particularly someplace like an online repository, it might need a URL. Um, yes, no, maybe, idiot.
Okay, so this opens up a different conversation here, right? Like, okay, so for example, like you guys notice here on my sidebar, I have two OneDrive folders that are, unfortunately, and I say unfortunately because this is, I don't choose to work this way. On Microsoft systems since Windows 10, they kind of coerced all their users to take basically all their key folders, their desktop, their downloads, their documents, etc., and those automatically sync up to OneDrive. And if you log into Windows with an email address, it automatically saves your stuff out in the cloud, which is wonderful if you lose your stuff, right? Like your computer blows up. But to answer your question, Greg, what it does is it works kind of in the way Dropbox works, right? Like you have a physical folder on your machine, that folder replicates to the cloud, but locally you still use the same paths that you do as you normally would. I will tell you though that I have my OneDrive is disconnected from my key folders on my machine. I do my own control of what goes into OneDrive, where most people's machines will automatically store here, you know. So I have stuff that that goes in there. So you shouldn't have to change anything to make that work. If it's listed as OneDrive here, it's still all folder relative, but you do have a physical folder on your machine where the files are located.
Right. Okay. All right. Thank you.
Right. And if you're running into any weird problems with that, you guys let me know and we can certainly take a look at that. I'm running into a weird problem here, and I don't know if you guys are spotting this or not, but when I go to rename these, right, like, all right, I'm going to open this one up. All right, this is definitely the B movie. But when I pasted these in, they didn't paste in the way that I wanted them to. And then the Shrek file is here, so I'm going to copy that and move it over to my folder. I'm not really sure what happened there when I did the copy paste before, but I'm just going to open it up to be sure. And this is kind of me being a little paranoid, right? So this is the Shrek file, and then I have the B movie file. Okay, so we have both those files. They're in our folder. You guys all okay? You've done those maneuvers?
And we don't need to rename them. You just wanted to rename it yourself, possibly, but we don't need to rename the files,
No,
right?
you don't need to rename it. The reason I needed to rename it is it's not the first time I've grabbed those files. So when they went into my downloads folder, it automatically appended /1, /2. And then my copy paste over wasn't a clean one either. I don't know if you guys were watching what was happening. I must not have been paying attention as I was pasting, but it's all okay now. I have the right files. They're in the right place. For you guys, it might be a little bit easier than what it was for me. All right, let's now go back over to VSC. I'm just going to take a look in there and go, okay, great, the files are there. You know, now I feel a little bit better. I am going to make a new program, and once again, it's doing the same thing it was doing last time. So I'm just going to exit out of there. I'm going to highlight this one, and then there we go. Okay, so I'm going to say mod 6 lab 2.py. All right, so there it is. All right, let's look at our instructions now. All right, so created the folder. We put the text files in the folder. We grab from here. And then it says open the B movie text file and create a script to get every line from Barry. Now this is really kind of interesting because we're going pretty quickly into like moving away from like opening a file to processing a file without really a lot of instruction. But what's really fascinating about this language is how elegantly it does it. You know, and it always has blown me away that it's so easy in Python to do some of the stuff that we're about to do. The way that I'm going to proceed with this is I'm actually going to write a function to do it, right? Because it tells us to, and it says, upgrade the program to use a function with 2 parameters. All right, well, let's take this one step at a time. Open the B-movie text file and create a script to get every line from Barry. Okay, that's pretty easy, right? That's just an open command, right? And then we're going to use a function with 2 parameters, character name and file path, and we're going to search the specified file for each line from the given character, and then we're going to try it on both movies, by the way. So we're going to experiment a little bit here. All right, let's come back over to VSC, and I'm going to do like step number 1, which is I'm going to create a variable called script, and we're just going to run the open command and grab the file. If you guys remember, first parameter is the folder name. And okay, I'm going to backtrack here a second. I'm going to do an F-string approach. I'm going to show you why. Because I'm going to say lab2 files. And then normally what we would do here is we would put hard code the name of the movie. But what if you want to use a variable instead? So what if you want to allow your user to type in the file name, you capture the file name, and then populate the file name into the folder path. So that's why I'm using string interpolation. And so I'm just going to create a variable called file name. I don't have it declared yet, but we will. Right. And then after the curly bracket, we'll say .txt. So whatever the file name is, .txt. So you're going to type B movie or Shrek, for example. We're going to open it up in read-only mode. And that needs to have quotes around it. I'm sorry, forgot to do that. And then we should just practice putting it on the screen, right? If you guys remember, we can do print. We can call the variable, use the read. And however, if I'm going to ask my users, you know, what file, I'm going to ask them right here. So I need to capture that. So I'm going to create a variable called file name, and then I'm going to do an input where they just type it in. And we'll say what file to open. And we are going to be tweaking this, by the way, as we go. All right, let's just try this. This is simple, but what this will confirm is that we can read the file. So let's do it. All right, so what file to open? I'm going to say B movie, right? I'm not typing TXT because that's going to be handled right here. There we go. And then it read it all in and put it all up on the screen as long as it was, right? Our first example, we had like 3 or 4 lines of text. Now we have like pages and pages. But do you notice how quickly it did it? I mean, it's like, boom, up there. There it is. Okay. Let's run it again. And this time we'll put in Shrek. And it did the same thing, right? Now it is putting in, oh my God, all these like weird like characters and stuff. I don't know what those are. I think those are like the characters for square brackets. I don't know, or a symbol, maybe like a music symbol or something. I really don't know what those are, but we could look at the file and figure it out. All right, so that's working. We are able to access our files. So this little piece is working, and this is really what I was testing, by the way. Now, I want to actually create a function now. So I'm going to get rid of some of this stuff here and kind of restructure it and move it around and do weird things with it. But I'm going to first create the function definition, and this is going to be called print lines by character. I gotta make sure I spell that right here. My fingers are not letting me spell it correctly. And then a colon. We were told that we're gonna pass in a couple of things. So I'm gonna create like a prompt, but I'm gonna do it in the function call, and then we'll predefine the movie perhaps. I'm not really sure how we'll engineer this, but what I am going to send in for sure though is going to be the file name that I'm opening, and then the character name of which I want the dialogue for. So in other words, like why this would be handy, like if you were given the role of one of the characters, like here's all your lines, just your lines, right? That's kind of what we're doing. All right, so that's what this thing is going to do. Now, because we're sending in the file name and the character name, this script command, or that line that I just copied, it's not a script command. It's the script variable, which is going to be opening up the file and reading it in. That can happen inside the function. Okay. And then we can do the processing. Okay. We won't need this either. But now I'm thinking like in the main run of the program, what are we going to be prompting for? So I'm going to do this. This is slightly different than what I did last time, by the way. So I'm going to create a variable called file, and I'm going to just do an input and say, what script to open? B movie, Shrek, whatever ones we have. I'm going to do a question mark instead. That's fine. We will capture that. And then we will have a variable for the character. And once again, we'll prompt and we'll say, and here I'm gonna be somewhat clever with this, is we can include the name of the movie right here, right? So we could say file, so it's a Shrek or B movie. So we're capturing those two pieces of information. And then once we've captured that, we're going to send it to the function for processing, right? So let's call the function, and then we're going to feed to it the file and the character, right? And then the function's going to handle all the work. So that's basically our main program body. We could, and I'm just kind of like giving you food for thought here. We could take these prompts, right, and just drop them in place of the variables here. We don't really need to store it. So you could do it that way. So this one would drop here. That one would drop here. I just decided to do them on separate lines. It's not what I did last year, by the way. But I think what I'm doing now is making more sense to me, at least in my brain. All right. The next thing that I want to do is I want to read through the file. So we already used the for loop to read through the thing line by line, right? We figured out that little thing. But I'm trying to think here, as we're reading through, how do we trigger it so that it only outputs the lines from our character? And so my brain tells me, right, and my experience tells me that I want to create a Boolean variable here that I flag. It's like a flag, true, false, to keep track of if this belongs to this character or not. That's what I'm going to do, and hopefully this makes sense to you as I do it. So I got this little snippet of code I'm dropping in along with the comment. So I'm asking it in the form of a question. Is this the character I want? I'm going to assume to start with it's false. I can't assume that the character I'm looking for is the first one speaking, so I'm presetting it to false. Then I'm going to run my for loop. So here comes the for loop. For each line in the script, the file, right? We'll start with the rstrip command. So we're going to take the line and we're going to run it through rstrip to remove any trailing characters that we don't need. But more importantly, we're going to strip any carriage returns from it. If it is the character I'm looking for, So if character is true, I will output the character's line. So I'm just going to put that one line up on the screen. Okay, so what's going to happen the first time? It's not going to print anything, right? Because it's preset to false. All right. So, okay, there's a reason why I'm doing this, and you guys are probably going, why is he doing that? Okay, well, here's the reason. The way that this is set up, right, is the name is listed first, right? And then their dialogue. Some lines are blank. The rstrip command is getting rid of the blank lines. These would be the /n's, right? We do also have a little bit of a problem because each line that has the character's name when they're speaking has the name followed by a colon, and that's not really a problem. That's actually an indicator that that person's about to speak. So that's what we can search for that and use it as a criteria to run. So for example, I'm going to write a second if statement here, and I'm going to say if the line that we're feeding in is equivalent to the character name, so Barry, for example, along with the colon at the end of the line, then we know it's a designator that that character is about to speak. And then I can actually put the flag to true. So I can say is character, that's going to now equal true. So now we flagged it to true. Otherwise, is character is set to false. So if it's not the one I'm looking for, then we just ignore it. So it's going to ignore a lot of stuff. Now, this seems kind of backwards because the very first time it's not going to print anything. That's kind of a given. Then we're finding the character, and if it's true and it loops back, then it will print the line, right? And then it will continue again searching. Alexis, I see you have a question.
Yeah, so, and maybe I'm just missing something, but like so based off the way we have it right now, it would never actually be able to, like, because, okay, so like the character name is its own line, and then his actual line of what you're saying is a second line. So once it gets to that second line of like what they're actually saying, wouldn't that then trigger it to false and you're no longer under that character, even though it's still that character's line?
No, I see exactly what you're thinking there, but keep in mind here. So for each line in the script, so we're processing a line in the script, and let's say we get to this line,
Mhm.
right? Right now the flag is set to false. It's going to read it in, right? And it's going to, all right, so it's not going to print because that's not what we want to print anyhow, right? Because this is set to false currently. Then it gets here and it goes, okay, well, that is the character name I typed in. I typed in Barry, and there's a colon that follows it. So now I'm setting the flag to true. So when I come back through the loop, then that's going to be true and the line will print. But what line is printing at that point? The next line.
So what if it's more than one line though? Because
The
wouldn't it
flag-
still end up going into that else statement after it does
Well,
that first if statement?
That's a good question. I guess you have to look at how it's structured. You notice how the really long lines are all in one line.
Oh, okay.
Yeah,
That makes
that's
sense.
that's the secret sauce, right?
Okay.
And then if you word wrap it, it looks like a paragraph, but it's really still one line. Yeah, but good thought for sure. All right, let's go ahead and try this, because this is, believe it or not, all the code for this. So I'm going to run this, and I guess I need to know, well, Barry is one, Janet's another, there's Adam. So let's try it with, so we're going to be prompted for what the movie, we're going to say B movie, and then we're going to be prompted for a character. All right, so let's try it. Here goes. What script to open? B movie. What character from B movie? I'm just going to go with Barry since we know that one for sure. And then here are all of his lines, supposedly. Now I would double check it, like for sure, right? But we saw this one, right? And so these are all of Barry's lines here.
What if we wanted to separate add an extra line between each line? Would that be possible?
Oh yeah, that would just be a simple output command.
Okay.
So like when you do this, when you print here, like for example, you could just add a blank print statement after it, or you could do, you know, a -- in there too. That would work.
Thank you.
That might be the fastest way.
Mine just like doesn't run. I can put I can open, like I can do the first two prompts, but after that, the output for the script that Barry has like said doesn't run. Like it doesn't show up on screen.
Why don't you share your screen with us real quick? I'm going to pause the now try it with the other movies. So let's open up the Shrek file here. And I guess we can use Shrek as a character, right? It's probably got a lot of lines in the movie, I would hope. So let's run it again. This time, let's try it with Shrek. So what script to open? Shrek. What character? Shrek. And those are all of his lines. Notice the extra space in between. Including the laughing and the sighing and everything.
Looks cleaner.
It's got a lot of lines in there. Yeah, it sure does. All right. But you know what I think is fun about this, right, is just the fact that we can process these really large files very, very quickly like this. All right, we're going to move on to the next lab exercise here. We are going to take a break, I think, coming up again here in a little bit, but we're going to keep rolling for now. All right. So I'm going to jump back out here. I apologize for navigating this way, but I don't want it to pop into the video there. All right. So we've already looked at the documentation on reading a file. Now we're going to also throw in the concept of being able to write a file or append to a file. So let's take a look at these commands here. So other switches that we can use on a file is we can use append and append. Now keep in mind, right? Like, so we already learned this on lists. Like if you want to add something to a list, you append to it. The fact that we can append to a file, once again, reinforces the concept that a file is a list of lines of text, right? So that's why we can append to it. So if you open up a file and you do an append, right? So here's the command for it, right? So we're opening up a demo file in append mode, meaning we can change it. Then we issue the write command, and whatever we write to it will get stored back into the file. Then the file gets closed. Now this is an extra step here, by the way, that whenever you open a file for writing, you should also issue the command to close it. And a lot of programmers do forget to do this. And why do you do that? Because what if somebody else wants to write to the same file? That happens, right? Especially in large complex environments. So you open it in a write mode. In this case, it's append. You write in your contents. That line of now the file has more content goes to the bottom. Then you close the file. The next command is we're reading the file in and then putting it on the screen. So let's just kind of see this, right? And just to show you that you can append more than once, I could do another write command, right? And just, you know, type in some nonsense here. And of course, there's no run button. Okay, well, that doesn't really help. But right, most of these like things have like a run button. Do you notice that this one doesn't, right? It must be a reason. But if I was able to run this now, that would be appended to the end of the file. I do want you to notice where it got appended though. right? Not maybe where you expected it to be appended. So if you wanted a blank line, you would also throw in a backslash n here in some cases. The other mode that we can open it in is just with the straight right mode. So we use the W switch, and then when we write into the file, it's not adding to the contents. It is now replacing the contents. Right? So this is destructive. So if I run this example, whatever was in demo file, that's gone. And now whatever you put here is what's there. Right? So that's kind of a concern as well. However, the fact that I can open a text file and change it, now that's powerful, right? Like you can change a file on my operating system. That's something that could be very, very useful, by the way. If you create a file using any one of these three switches, so you can use X, which is a straight up to create it, or if you issue the append or write command and the file is not already present, it will create the file for you. So you don't have to go into your file system, make the file, and then add contents to it. That command can directly create it. Now, if you're not writing directly to it right off the bat, you use X. My habit, real frankly, is I just go right to W for most of this stuff, like to create a file from scratch. So that's something you can experiment with. And in fact, you know what, we can do that. Well, we should probably create our lab 3 file here. So let's just go ahead and do that. Mod 6 lab 3.py. And I'm just going to go to W3 Schools and borrow their code, by the way, so I don't have to type anything. And I'm just going to run this just like this and see what happens. All right. So here comes the run. It did it. I don't have any output in the console, but the program ran, it didn't crash, and it brought me back to a prompt. So now the test is to go and look for the file it created. So I'm going to go to my file system, and it's going to be in the root folder. So, and there it is. It wasn't there before. Why did it go to the root folder? Well, that's where I told it to go. I didn't put a folder in front of it. All right, since we're here, let's go ahead and make a folder for the lab 3. So we'll call it lab 3 files. And let's test that one more time. And I'm going to change the name of this. I'm going to call it your file. But I'm also going to append to it lab 3 files /. Once again, I'm going to run it. And you know what? I'm going to do like, this is like goofy programmer stuff. Put a little message on the screen. Process complete. You know, goofy, but totally not necessary, but just to kind of make the point, right? So it says process complete. Let's go look. So I'm going to go into the lab 3 files, and there's your file. If I open it, it's blank, right? If I want to add something to it, so this is where we can kind of leverage up their example. I can just say f.write. I don't know, something. And then also, you know, it's a good idea really to close the file too. So we say f.close parentheses. This releases it back to the file system to do whatever. And then I can also print that out. So I can say print f.read. I'll leave the process complete in there, but just to show you that the whole thing works. So here comes the save. Here comes the run. Oh, it doesn't like something I did here. Oh, why can't it read it?
You closed it.
I closed it.
Is
Yeah, closing it releases it. So like what I would have to do then is I would have to say, well, look at the W3 examples here, right? When they were doing this, right? They closed it, but then to read it again, they have to open it. Right. Okay, I'll just copy their code. I'm just feeling too lazy to type right now. And then I will change the name. Now let's run it. All right. Oh, okay. What did I do wrong this time? Because I'm batting 1,000 here, right?
You need
This is where you
to
quit coding and do a different job, right?
you need to state the folder.
Yeah, I don't have the folder path here. Right. What was the error message? No such file or directory. Okay.
On you.
Saving. Yep. As long as you figure it out, it's all good. Right. And there you can see that's the contents. We can double check the contents in the file system. I can open it up and see that my text made it inside there. However ugly and primitive that is, but it is working. Right. Okay. Let's go back and look at the rest of the material here. We are going to work with the date time object again. So we're going to be throwing a timestamp in on our AMP. We've done this before, so I'll show you the code on that one. So we don't need to lecture on that. There's another thing that we're going to throw in here, and this takes us actually to a different website here. And we're looking at what we call the OS module in Python, which we're going to import, by the way. The OS module gives us a bunch of different commands. Let's look at what these commands are, but they're all related to the path of the file. And well, figuring out, is it there? Is this a directory? Is this, the correct name for example? And they have a couple of little examples here to show you how it works. And rather than spend a lot of time walking through that web page, I'm just going to show you how I'm going to employ this. And basically, we're going to use one of the particular functions, which is to look and see if the path, and I don't see this one listed here, but there's a command in this that does the path exist? So in other words, is this a real folder path? And that is actually very, very useful. So in other words, is that file really there for us to open it? And if it is there, we open it. If not, we don't, right? So that's basically going to be our operating paradigm. All right, so let's read the instructions here. It says, in your project folder, create a directory called lab3 files. Been there, done that, right? Create a folder inside of there called receipts. Okay, so let's go do that. And I could do it from VSC. Not a huge fan of doing it there, though. So I'm going to do it from my file system. And we're going to call it receipts, right? Spell that correctly. I before E, except after C, right? All right. Continue asking the user for an item and cost as long as they choose to repeat the process. For each iteration, create a new file with the following naming convention: order N, order -N, actually, where N is the order number. At the start of the program, find the current order number based on the file names in the folder. Okay, this is a lot more work than anything we've done so far. So we're going to take this very systematically, but I think if you're listening to this, right, you can tell it's a loop. In fact, a couple of loops are going to be running here. All right, so I'm going to do this first. I'm going to come back over to VSC. And I know we have like these little examples that we did here at the top, but you know what? This is all testing to show the write switch and the read switch and all that stuff. So that's all going away. We are going to use the date time object because anytime we put in an order, we're going to timestamp it. So I'm going to say from date time. Oops. import date time. And what that's going to give us is a date and a timestamp. Right. And think about it, like when you place an order or you go to a store and you buy something, all the receipts are stamped that way. It's helpful, right? Right. Okay. We're also going to import the OS library because we want to use that to check for valid file paths. Now, when we start out, our very first order number will be set to 1. So I'm going to just start that right at the top. I'm just declaring, I'm saying, okay, our first order number is number 1. All right. Next, I'm going to set up a while loop forced to run. And I'm going to ask this very simple question. I'm going to say, if, and you guys follow this syntax here, if the operating system path dot exists, so this returns a Boolean, a true false, right? And then as parameters, and I'm using the F string formatting here, we're going to go into the receipts folder. And then we're going to check to see if a file exists. And I want you to follow my logic here. We were told to name every file order dash order number. So I'm going to order dash, and then in curly brackets, order underscore num. And then after the curlies dot txt. So this is going to return a true or false. If true, then the next file number that we want is the next file number up. See where I'm going with that? Right. So this is going to check, is order dash one dot txt present? If it is, well, then the next add 1 to order number and do it again. You know, so I'm just going to say order num plus equals 1. Otherwise, if that file's not there, we jump out of this loop. Okay. Well, what happens next? Well, then we build the order file. That's what happens next. This is just to determine if we're overwriting something, basically. We're just setting order number to the next available number. All right. Once again, I'm going to set up another while loop here, force to true. And here's where we're going to do the prompts that they asked for. So we're going to have a prompt for item, and I'm going to say input, and let's do some parens here. I'm going to start with a \T. We're going to tab in on this, and I'm going to say item colon space. And then I also have one cost. And I'm also going to set up a variable for time, and then I'm going to let that automatically timestamp. I'll put that timestamp statement in its entirety in the chat, so you guys don't have to type it. And I want you to notice there's kind of a date time now grabs the current date and time off of your system. The STRF time thing makes it look kind of normal. It doesn't make it look like it's coming off a military clock or something. Alexis, you have a question?
Yeah, for the first while loop, do we need the like lab3 files in the path?
Yeah, you're spoiling my fun, Alexis.
Oh, sorry.
No, she's on to something like it, but she's right though. Check it out. My file is here. Receipts is 2 folders deep. Ah, yeah, she's onto it. Good catch, by the way. Right. So this should be lab3 file. See, I was going to let it run, And then we'd be like, oh no, what happened? You guys think I do that like unintentionally sometimes. Sometimes I do, but sometimes I do it very intentionally. All right, so we're prompting for the item and the cost of the item, and then we're giving it a timestamp automatically, storing those all in variables. And now we want to write that to the file, and we want to create a new file if it doesn't exist. That would be the action. So I'm going to create a variable. I'm going to call it in the singular receipt, right? And that will use the file open command. And inside there, we'll do f-string approach. And what we're sending in, notice, is this syntax. This goes between your parentheses, folks. Or actually, yeah, that wasn't a very good paste. You'll have to fix that to make it work. It wasn't a very clean copy paste. Greg, question?
Yeah, real quick. Just rolling back to the path there. If you would, at least I found that if you drill down to it and then right click on the file name, it'll give you the relative and absolute file paths. At least it does in code. So over in the left hand pane, yep, just go down there and grab like the and then the receipts. Go in the receipts folder right below that, and right click, and then you can look at it. And if you right click, and at least mine, it gives me the context menu that says you can get the copy path or copy relative path.
Yeah.
And then drop that right in to shortcut the where the heck this file actually lives.
Well, thanks for the tip. And you know what? I don't normally use this tool inside of here, but yeah, that is a thing, right? So like if I copy the relative path just to show people what output that is. But notice what it does though. Do you see a problem with it? It uses the
The
Windows.
slash is, yeah.
Mhm.
So if I were to move this to a Mac or a Linux system and run the same code, I'd have to go back and re-engineer. Like this will work on Windows with the backslash, but if I move it to another system, it won't. And so you're better off doing the forward slashes. That would be my only comment on it.
Mhm.
But that's helpful though, absolutely. All right, so this is going to open up that path and the order number, which now has incremented by 1. So this would be order number 2 or whatever, in write mode, and create it. And then what we need to do is we need to write in all of our stuff. And so what I have here, and yes, I'm cheating, folks, sorry, but I'm going to write that stuff. Notice one line at a time. I'm doing you a solid and putting it in the chat there. Right. So we're going to put a little header on it, order with the order number, what the item is, what the cost is, both tabbed in. And then it's going to have a little purchased thing in there with the time and the date. And you know what? Maybe that should also be tabbed in. So I'll do a \T there.
So Ty, I got a question. So I'm looking at mine and line 19. When I'm looking at mine, the cost is a yellow squiggly line underneath it. So it's not defined.
Which one has which one? This
that
one has
one,
the
yeah.
code?
It's not defined, but it is defined. Maybe it's just my
I guess I would
BS.
have to. Well, you know what? Let's take a quick look at your code if you don't mind. Why don't you share your screen? I'll pause it in. All right. So one thing that we did here is we had some extensive conversations about files and namings of things, and how the program works. And in the intro, and I forgot to hit record, I did add a close command to release the file back to the operating system. We incremented the order number counter, And then we just added an if statement here. So if a person does not want to enter another thing, we're out of the loop and the program is done. If they want to keep entering order numbers, they would just type a lowercase y, and we would just keep creating new files. So now what we have to do is we have to test this and see if it works. We want to run it at least once and then create a file, go take a look at the file system, and we'll come back and run it again and see if we can keep adding new files without overwriting the old ones. That's kind of the plan here, right? Control S to save. I'm going to go ahead and do a run. All right. And I'm already at the item. So unbeknownst to me, I'm just entering items. Okay, I'm going to say M and M's cost. Oh, what is it for a pound of M&Ms these days? Like $4.99 or something like that. Add another item. I'm going to say no for right now. And that's just going to pop me out, right? Now, we don't have a routine built where we're reading the file at this point, but we could read it back. But we can go to our file system and just take a look. And so I'm going to go look at my receipts and check it out. There's an order number 1. And I open it, and there you go. Now, I will say I don't like the tabs. So I think I'm going to fix that going forward. I'm going to move everything back over to the margin. But notice the stuff I entered manually is there, and the timestamp is there. Alexis?
Yeah, again, probably just missing a very small thing, but mine did not do the 1. It like straight up says like curly bracket order num in the file.
Oh, did you put the F in front of the F string?
Yes.
All right, let's pause and take a look, Alexis. All right. So now that we've kind of solved some little problems, let's try running this continuously and add a few things. I did get rid of my tab stops here. I wasn't liking how that was looking. In fact, I'm going to get rid of it here as well. I think that's silly. All right, so saving, running, and now we're going to add a bunch more items. So ham 329, yes. Soda 199, yes. Pizza 1750, yes. Whatever.
நான் முடிச்சிட்டேன் கோட் முடிச்சேன் நானு கோட் கேம்.
Okay, that's going to be on the internet, sorry. Yeah, and you notice on this one I typed in free. It's okay that I'm doing that. Yeah, Python
Sorry.
doesn't. Yeah, Python does not care. Isn't that weird? Then I'm just going to say no. So how many files should I have now? 1, 2, 3, 4 files, 4 new files. But what should those files be called? Starting with what number, Sonia? 2. Right, because number 1 was already there. See, that's
Right,
kind of
starting at 2. Exactly. Yes. Correct.
so that's kind of the point of the program. So here we go. Order 1. That's my first M&M's thing, and it was tabbed over. And then order 2. Right, that's where I fixed it. Order 3, order 4, order 5. Now, this is, mind you, this is very primitive what we're doing here. But the fact that we're creating new files, it's auto naming them. It's not getting rid of the old ones. And granted, it would get inefficient. Like once we had like I said, like 1,000 files or 100,000 files, because that first while loop would keep running, incrementing the counter until it got to that point. There would be some inefficiency there, but you could always go in and reset it, right? Or put it in a new folder or whatever. Maybe it would be fine for like a month or something. But a pretty neat little routine here for creating stuff adding new files, writing to them, and then auto naming them. It's kind of a helpful little practical kind of thing. All right, I'm going to get all this stuff out of the way here. And we are going to move into lab number 4. And I'm going to bring those instructions up on the screen here. So let's see if we can find those.
Keith, this is Caleb. I've got a question for you.
Absolutely.
Can I share my screen? I'm getting an error message with file not found, and I believe I've got my file path all correct.
All right. All right, we're moving on to lab number 4 now, and we're going to be using the same tools that we've been using. So we're going to read a file, write a file, and deal with the operating system as well. And I'll give you all those pieces as we kind of move forward. It says create a folder in your project folder called lab 4 files. This is a manual process. You might want to do it through VSC. I prefer to kind of do it from my file system. So I'm going to go back up to the root of my module 6 labs. I'm going to create a new folder and I'm going to call it lab 4 files. Okay, there it is. It is now created. Now we're going to work on our program, and the program says create a class for a person object with the following properties and methods: first name, last name, and age. It'll have some of the standard methods, right? So the init method, the constructor, the string method for doing output of all the internal variables. And then we'll have another one called output to file, which guess what? Will output to a file, right? So that's going to be built into the object, right? So the object will be able to write itself to a file. We're going to pre-populate a list of at least 8 people. And I will, by the way, provide that for you. So you don't have to type it all in, but you could easily do it. Create a menu and associated functions as described. So we're going to list the files. So it should list all the files in lab 4 files. So we're going to have to learn how to do that. We're going to create a file by age. It should create a file with a name specified by the user and contain all people within an age range specified by the user. So in other words, we're going to take our list of people, look at their ages, and depending on their ages, put them into a file. So this is kind of a couple little things going on here. It's like a little more complicated. Then we're also going to do the read file, which is get a file name from the user and output the content. So that should be easy. And then we'll also be able to delete a file. This is kind of interesting. We're now going to do the CRUD operations. If you think about this, right? Create, retrieve, update, and delete or destroy, but we're doing it with files now instead of with contents in a list or a dictionary or something like that. And then we'll also have an exit. Some of this structure is kind of familiar, so it'll be kind of like some of the apps that we've built, but we're throwing in the file stuff with it in the mix. All right, let's go ahead and get started on this. I'm gonna kind of collapse all my stuff here in VSC. I'm going to make my mod 6 lab file. It looks like I'm going to have to move it. So this is mod 6 lab 4.py. It ended up in my lab 3 folder, and I don't want it there. And once again, this is one of the reasons why I do not like VSC. So I'm going to move it out here and say move it. Yes, I want to move it. Thank you. Okay. So now it's out on the root level. I do have a lab 4 files folder. So all the stuff that this is going to be working with file wise, they're all going to be in this folder here. It's all the files it creates. All right. Let's start the process of coding here. I am going to be using our helper file on this one. I'm noticing that my helper file is not in this folder. So I'm going to go out to my file system here, and I'm going to go to my module 5 labs, grab my helper.py file, and then I'm going to move it into my module 6 labs folder. So right here in the root. Okay, so you see it pop up here in the sidebar. For people kind of watching the video, right? Just a review of what's inside here. We have a get in, get into range, get email, and get letters. These are functions that we've written before. And we're going to utilize at least one of these. It looks like I'm targeting to use this one here. So I'm going to close that for now, but I just kind of want that for context. So I'm going to do the imports. I'm going to say from helper import get int. Right. We're also going to import all the OS tools so that we can check file paths and stuff. We were told to create a person class, so I'm going to start with that. Let's do class person colon. We'll do our init function, double underscores here. Have the self-referring, and I'm already messing up, but hey, that's how it goes. And we were told we need a first name, last name, and age. So first name, last name, let's throw a colon in there, and let's assign all of those as they're incoming to things named the same thing, but with self in front of it. First name equals first name, self dot last name equals last name, and self dot age equals age. That's our constructor. We're also going to put together a string method here. So let's predefine that. So double underscore str. And then we'll do the self-referring. We don't need to send anything in. We just need to put stuff on the screen or generate the text, basically. So we're going to have a return statement here that I'm going to copy and paste in. And I pasted in too far. So we're just going to send back the last name, comma, first name, colon, age. That's the format I'm going to use. All right. I am looking at like one thing that we have this other function that we're supposed to write. And I'm going to put it in here, but then I'm noticing last year, we must have ran out of time last year because we never wrote it. So let's see if we have enough time this year to do it. And I'm looking at the clock too, so I want to be really mindful. And what I put last time was this is optional. And for now, I just had pass in there because we hadn't like actually engineered it. So I'm assuming I ran out of time last time. So we'll come back to this. Let's say time permitting. But I think we should be able to do it. Okay. Next, we need to create a list of people objects. So we're just going to call it people. And square brackets, oops, not curly, squares, split them. And then, folks, I'm going to give you all this stuff in the chat. So type what I did, and I'll give you what goes in between, which is that. So I have a pre-configured list here of individuals. I have no idea where these names came from. Well, there's this thing when you learn about AI is often trained with what we call synthetic data, right? Like data that's invented for the sake of training the AI to do its work. I'm assuming this might be synthetic data. So there's our list of person objects. All right, now I'm going to go down to the bottom, and we are going to get our big while loop going to run the program. So here's the while loop, set to run to true. I'm going to do a little menu creation here. I'm Saving you guys a little bit of time. And then we're just going to use kind of our standard approach here. With an if statement, once again, this is a lab, so I'm saving you a little bit of time. I'm trying to be mindful of the time because it's already 9 o'clock. Kind of the same approach we've been doing, right? We see the function names here, they're underlining yellow. We're going to pre-create their structure and then populate them. I do want to kind of take a look at the instructions for just a moment here. If you guys want to go ahead and start pre-building the structures, you can do that. I just want to remember all the tasks here. So I'm just going to start building these one at a time. Right. And then we go for the low hanging fruit. Right. The easiest ones first.
Can you scroll up a little bit?
More?
Yeah, I was just trying to see what you did for the string function. Okay. All right, thank you.
No problem. Last one is delete file. I think I will be brave and type that one in. So there we go. We have kind of our basic structure set there. And I'm starting to think, once again, what is the easiest task, right? And none of these seem particularly super easy. And I think like create files, probably the most complicated one. I'm looking at my code and that was the longest one. I think maybe either list the files or read a file. And I think maybe it's helpful to list the files first. So maybe we just work top down on this. So I'm going to go up to list files. And the first thing I'm going to do is I'm going to just create a variable called files. And what I'm going to do with this is going to call the OS thing. And this is kind of a weird command, but it's the very first one on the list here, which is list directory. It's going to show me the files in my folder. Okay, which folder? Okay, well, the lab for files folder. You do have to put the / in there at the end, right? So it knows to go into the folder. So this is just going to reach into the folder, tell us if there's anything there. Next, we'll put in a little for loop, and then we'll say for each file name in that folder. So I want you to get an idea of what's happening here. It's grabbing the list of files from the operating system and it's dropping them in this variable. And now we're going to traverse that. It is a list of files. That is the structure that comes in. We're going to run a print command here now to see the file. So I'm going to use the F string approach on it. And last time I did a tab, so I tabbed them in, and then I just did curly brackets with the file name. Right. Unfortunately, right now this folder is blank, so otherwise we could test it. But I think what we have to do is we're going to have to actually create some files to make sure that that's working. Another way that we could test it, you know what? You guys don't have to do this testing, but I could take, for example, this goofy file we created before and just drop it in here for a moment. And then I'll do a run on it just to make sure that it's working. So I'll do a save, and then we'll run it, and I'm just going to do 1, Oops, wait, I typed it in the wrong spot again. Type 1. And there it is, outputting the file name. Okay, so it does work. I do not want that file there. So now I'm going to go ahead and exit. Oops. All right, I'm just going to close that. I did not mean to do it there. Control S to save out here. All right, so list files is working, but this is a pretty nice little command. But what I like about this is that it grabs the list of the files. You can store it, and then you can traverse it and output it. So if there was like 20 files there, it would output all of them. It's pretty handy. All right, I think next one that we should do that makes sense to me is to do the read file, right? And if we're going to read a file in other words, we're going to take a file that's in our folder and then display it. The first thing we want to do is see a list of the files, so I can call list files to run so we can see the list of files we have to choose from. And then we can do kind of this combination of building the file name by virtue of adding the path, the folder name, to a prompt that the user can type in the file name. So follow me on this one. I'm going to say file underscore name. And then I'm going to put in double quotes here, lab for files / the folders pre-built into it. Then I'm going to concatenate to it the result of an input prompt where I ask the user to enter a file, or enter the file, maybe is a better way to say it. So they're going to see the list, and then they're going to type in myfile.txt. And then it'll go into that variable. So now we have to do this check, and you think about like how software works. The files got to be there in order for us to actually look at it. So we got to test for that. So we've kind of already done that. So I'm going to do an if statement, and I'm going to say if the operating system path exists. So the thing that we just put together, and what are we looking at? The file name that we just built, the folder and file name. So if that exists, if that's true, then we'll set up a variable called file. We'll open the file. Now, you'll notice that in this approach, I don't have the second variable in there. Could or should I add that? That's really a question.
Yes, since we want to read the file, yes.
I mean, yeah, that would be the assumption. Strangely, what I'm kind of hitting upon here is you can actually leave it off. And guess what the default is if you don't put a switch on it? It's read only by default. But it's probably wise to put in the R switch there. Okay. So we're going to read it in. We're going to store it in the thing called file. Then we'll print. And we'll say file.read. Well, this goes right back to the first thing we learned tonight, right? And then, even though we're not opening it for writing, it's still considered good etiquette to do a file close command and just release the file, just in case somebody else wants to manipulate it or see it or whatever. And if the file does not exist, we need an else. And it can just be a really simple statement like, can't find that file. Right. And what might trigger that is somebody, I mean, because they looked at a list of the files, so those are the ones they should type in. But what if they just typed it wrong or put in an uppercase letter? One really funny thing happens when you're working in modern operating systems, by the way. If you're working in Windows or the Mac OS, and I don't know if anybody's realized this yet, but when we work like on a Linux system, the file and folder names have to be precise all the time. So if I call in a file and the first letter is capital, and I put in a lowercase letter, it's not going to open it, right? Same thing happens on a web server. The Windows and Mac OS, however, allow you to misspell. And if it kind of reasonably finds it, it still opens it. But my tip for you guys is don't ever assume that that's like how it's always going to operate. You know what I mean? You want the precision, because when you leave like consumer operating systems and I'm thinking the Mac OS and regular Windows, it'll be forgiving, but it will not be when you put it on the server. The servers want you to be precise. All right. The next one that I'm going to do is also the delete file. And you know what? Maybe, well, we have to have files to look at before we can read them. Let's do delete, and then we'll do the create. So, all right. If you want to delete a file, I think once again, you want to look at the list of files that you have in order to be able to make that happen, right? Like, which file are you going to delete? Well, let's see which ones are there so I know which ones to delete. Okay, so first we list the files, and then we kind of follow the same thing we did with the read file. We want to basically use the same prompt, right? We like, which file are you talking about, right? So that's identical. There's no change to that. It's in the same folder. They still have to type it in correctly, and then we're going to capture it. And then, of course, we're going to run an if statement right after it. So the if statement's going to say, the same, we're going to start the same way, so we can copy that statement. So if that exists, if that file is there, then we'll use the same type of command we would use on a list. And I don't know if we've ever used this command on a list, but there's a remove command, right? And we're going to remove the file name. So we kind of treat it like a list item. That's really weird, but it works. It removes that item. If the thing is not there, so if it flags as false, then we just give them, well, we can use that same error message, right? Can't find that file. What are you trying to delete? Well, we can't find it. So the read file and the delete file, not that much different, right? We just use the remove command to get rid of it. Right. I'm doing a Control S to save here, by the way. You guys all good? Can I scroll? All right, I'm going to scroll up to create file. This one's going to take a little bit more work, but we can do it. I had a little comment that I typed up last time I did this, and of course my word wrap's not on, so you can't see it, but so this should create a file with a name specified by the user and contain all the people within an age range specified by the user. So we have to do, so we declare the file name and we pick which people in our list are going to be in that file. So like two things to do. All right. First, we have to get the user to type in the file name they want to create. Okay, so we're going to make it look a little bit like this. So I'm going to copy this prompt here, right? Because it's going to begin the same way. We're really going to concoct the file name and the path name first, and then we're going to issue the command to open it. So the prompt is the same. Enter, maybe we say the new file name, right? Just to indicate that it's new. And well, they're gonna type in something like my file. We'll add the .txt for them, and we'll do that after this parenthesis. We'll just put a plus sign here, and then inside double quotes .txt. I mean, I guess you could have them type the TXT, but I think this is safer for right now. This is how our, our modern operating systems work anyhow. Now I'm going to make a new variable called file We're going to run the open command. We're going to use the file name and path name we just created. And then we're going to use the W switch to write. So we're creating a new file with that file name. Okay, so those that may have coded in the past can maybe start asking questions. Should we check to see if that file name already exists? Yeah, you could do that whole thing. We're going to assume no, though, right? We'll come up with unique names. All right. Next thing that we want to do is if we're going to set an age range for who goes into the file, we better prompt for it. So let's create two variables. One's going to be called minimum age, and then we'll use our getInt function to make sure they're typing in a number. So enter a minimum age, and then we'll duplicate that and say max age. And then, we can copy that and just tweak it. Maximum age. Right, now that we have that information, keep in mind, the file's been created, it's opened in write mode, and now we can add stuff to it incrementally. So I just call file.write. We'll use the f-string approach, and I'll show you the prompt I wrote up last time here. So this is going to go inside the double quotes. So in other words, we're going to add to the file what we're adding to the file, including the minimum and maximum age, so we know. That's written into the file. It's helpful, right? And then we're going to go into a loop, and in the loop, we're going to process through our list of person objects called people, right? And we're going to check the ages to see if they're in the range. If they're in the range, we're going to take that person that we found in the list and we're going to write them to the file. And if you think about all the little maneuvers that we're making in the process of doing that, it's actually kind of impressively small amount of code. So that for loop is going to traverse basically this people list, which is a list of person objects, right? So it's going to one by one go through those objects and all their stuff. Right? And then as we go through each individual object or person with all their features, we're going to ask a question. We're going to say if that particular person referred to as P currently, if their age is greater than or equal to the minimum age, and if their age is less than or equal to the maximum age. If that's true, right, they fall in the range that we want, then we'll issue the file write command, and we will write them into the file, and inside the write, we'll create a new line, and then in the curly brackets, write their object, their person object in there, which will use the string method in the object to do so. Okay. Yeah. Now, if you want to know what the secret sauce is to writing this optional method here, what it would be, right, is basically if this was true, we would call that function here, and then the writing of the file writing would happen here instead. That's all it would be. Very, very simple. So if you want to try that, I'll let you do that. We're not going to do that because we are really tight on time. We have a little over a half hour left. Just go back to the thing that we just wrote here, just so for those of you trying to type it in really fast. I'm going to go ahead, do Control S to save. I'm going to go ahead and run this and start trying it and see if it works. So let's see what happens. All right, let's try listing the files. Okay, there's the goofy file I threw in there. Okay. I think we need to create a file so we can read it and delete it, right? Well, actually, you know what? We can do a delete and I can get rid of my file. Right, let's try that. Let's do number 4. Enter the file. So I'm just going to say my file. Were we assuming that we're typing the TXT, or is the user? Yeah, now I have to look at my code.
We're
Okay.
adding it.
Yeah, we have to type it in. So if you want to delete, you have to know how to put in the file extension. Okay, no error messages. That's good. So now let's list the files again. Okay, it's gone. All right. Let's go do number 2, create a file, enter the new file name. I'm going to call it old people. Or how about old ones, something like that. .txt. No, we're not going to add the txt here, right? So I forget like where we're doing this. Enter the new file. Okay, let's just call it old people. All right. Enter a minimum age. I don't know. How about 55? Maximum age, I don't know, 120. Most people live that long. Now, hypothetically, I created a file. I can see in the sidebar there, it did create one. So let's just click on that really quick and see if indeed there's old people in the file. Hey, check it out. They're all over 55 and under 120. So it did work. All right. So let's go ahead and create another file. Let's do this again. Let's call it, I don't know.
Damn kids, get off my lawn.
Easy now, Greg. We'll say a minimum age of, I don't know, 1, maximum age of, I don't know, let's say 40. I don't know if any people really fit into that. All right, let's click on it and see what's in there. Okay, it worked. All right. Now let's go ahead and use what we have inside the program here to read the file rather than using VSC to do it. So I'm going to type in 3. I have my list. So now I'm going to type which one I want. And I'm going to say old people. Do I need to type TXT here? Yes, I do. Okay. Let's read the other file. Let's go ahead and delete a file. Probably want to delete the old people. Let's list again. It's gone. And you know what? Let's exit. I think everything's working. So we got that all done. All right. I'm going to go ahead and stop this video so this completes all the labs.